Hi guys, my name is Nitin. I work in the Faucet team over at Arista Networks. Our whole team is out here today. We are excited to be here. We got our code ready for the Plug Fest, which was held yesterday, just maybe 2 weeks back. So we're going to talk about our software development cycle, how it worked out, and it's going to be a list of decisions that we made that in hindsight we could have done better, but hopefully it helps other switch vendors, not make the same mistakes that we did, maybe make entirely new ones. So this is, I do coding for a living, so it's from an engineer's perspective. We have been supporting OpenFlow for a while now, 7-8 years at least, and this was the single table implementation. We are familiar with scale issues, deployment issues, and customers always complain about how they didn't want to write vendor-specific code on the controller side. There used to be experimental versions that you could write and send special flows down to Arista switches, and we supported that for a while, but not too many customers were happy about it. We talked to Faucet initially in 2016, according to my email traces. Real work started in 2019, earlier this year. And this was basically because a big customer said jump, and we asked how high. So we started working on Faucet. Arista management did a good job staffing up the project. We had people with expertise up and down the stack, and all of us came with a lot of routing and switching background. So in some ways, it was more like an unlearning process because OpenFlow works differently. And it's, for other switch vendors, I'm sure they went through the same process, but it's kind of a pain to give up on your switching and routing expertise and relearn the whole networking thing, right? And so anyways, we thought OpenFlow switches are done, and we have a crack team like this, so how hard can this be? Like all the software projects I have worked on ever, we underestimated this one too. We were in denial. We were in denial for the first part. We looked at the specs for Faucet. We looked at the pipeline. We looked at our chosen ASICs pipeline, and it seemed all doable, right? I mean, you look at ether source, each source table, and you think that you can put it in the L2 table, or the FIP table goes straight to the ASIC FIP table. It's a 1:1 mapping. We picked a real easy test to start with, the Faucet tag test, because switching is easy compared to routing, and tag because, well, I don't have to pop the VLAN or push the VLAN, right? So it's supposed to be easy. And there were 4 tables over there, VLAN, each source. I'm sure you guys are all familiar with how the tables look like and everything. And we went the TCAM approach because we didn't want to write code for the other parts of the ASIC, the shortest path always, right, as an engineer. The issue was that all the tables were looked up in parallel. We were ignoring goto. We thought we'll worry about that later. And when the packet came, and it would match flows in all the tables, it would match flows in all the tables, and you would look at the actions, and if the actions were different, you would combine them. If there were conflicting actions, you would use some kind of a priority to figure out which actions to use. And the first test passed. And this was a milestone for us because I don't know about other switch vendors, but we have our switches in the lab somewhere, right, in the data center somewhere. You don't go down and hook up cables and whatnot. It's all done via some script somewhere. The last time I hooked up cables to a switch was, 20 years back at Cisco, when I used to work at Cisco or something. So it was a milestone for us in the sense that we, instead of a namespace .dot, we used a real host and we connected things together. We got the Faucet test to pass. So it was a milestone. Next thing was when I was ranting at Brad and Josh about how the Faucet tables matched ASIC tables only in name. The functionality expected was very different. You look at the TFM, and it says that VLAN can be assigned on dest MAC, EAT type, source MAC, import, and no ASIC does that, right? I mean, you assign VLANs on import. The last time VLANs were assigned on source MAC was, 1965 or something? Nobody does that, right? But when you got the TFM and you parse the TFM, it says that it can do it. So you start thinking that maybe the approach we took of assigning a Faucet table to an ASIC table from a commercially available ASIC, not something that we would create by ourselves, might not work out. By this time, we had 3 other tests passing. Management was happy, right? We were making progress. So that was our phase. Bargaining. This is the hacking. This is the hacking phase, right? We kind of realized that maybe there is no use case for matching on a dest Mac in a VLAN assignment table. And the hack was like, you look at the flows and you figure out what the router MAC is. So if you figure out the router MAC, you can send the packet down the routing pipeline and decrement TTL and all that stuff will work. We did that for one test. The second test had 2 router MACs. So we did that for the second router MAC. And if you do it for 2 router MACs, you figure out that, this is not going to work, right? Because now you got to design it for N router MACs. So the other thing was like from the 5th table, you want to look at the DMAC which was set and send it out a particular port. We decided to build a software ARP table from the flows that were coming in. And we figured that this was going to take way more time, and it didn't seem very confidence inspiring because it was just hacking, right? So that was our implementation reality. We were making test pass, but we were not doing it the right way. It seemed more like we were taking on more work than was necessary. All this time, I think you guys, your Faucet team was great in helping us out, right? I mean, we had questions about every test, why it was failing, and what we could do differently. And thank you for all the help. Depression. So, as with all software projects, you come to a point where things are not looking great, right? You have too many bugs. It just seems like maybe you should look for a new job or something. And gleaning information from the flows was not working out. We knew from previous experience that if you had vendor-specific code, right? If you had a Arista TFM or something like that, nobody's going to buy that, right? It's if vendor name is equal to, I think I got that from Office Space, Initech, but if you have code like that in Faucet, customers are not happy about it. Right? Can you imagine writing controller code which says that if Arista do this, if Cisco do something else, or it's a mess. So our plan was to go with generic TFM. Our plan was that the switch API will remain generic. We won't pollute controller code. We'll stay away from it. The only time we really looked at Faucet code was when we were debugging tests to put tag PDB, or PDB to look at what was happening over there. And then finally, we came to accept it. Do the right thing. Do the right thing it's easy to say now, do the right thing. We did the right thing as a last resort. After exhausting all possibilities, we finally, we tried to hack our way out of it, right? And so we decided that each table in the switch had to be very, very flexible. If you couldn't use part of the ASICs, we're not going to get hung up about that. All our engineering trade-offs are going to be to make each table flexible according to what we read in the TFM. We won't have vendor-rich specific code on the controller side. And if it gets more complicated, well, we'll worry about that, right? We'll do it. So our current state, right? We did this, and what do we have now? We had the Plugfest, which all of us did great. We all passed the test and all that. Stacking worked great. We had a hackathon at Arista on Friday, and we did stacking for the first time. The same team, Arista pushes MLAG, and there are a lot of advantages to MLAG over stacking, and but we did stacking because it was possible, and we got it for free. We have a lot of switching and routing test passing, 802.1x passing. And when we did that, we got stacking for free. Basically, it was just a configuration thing. So this is where we are right now. And we'll see we have 90% passing. The 10% which are remaining are usually the painful ones, right? It might take us a lot more time to get to the other 10%. So, but this was our experience. And if it wasn't for the Faucet test suites, it would have been practically impossible to come to this point. So it was good to write some code and have some regression, and it really helped us out. So if you guys have questions about our development process, what we did wrong, we did a lot of things wrong, right? I mean, Yeah, go for it.
Okay. was just curious when you said you oriented. So how do you get a TF find a particular hardware in the
So routing and switching is easy, right? You can kind of figure out whether a packet needs to be routed. You could use metadata. Anything else? They sent this out here in Doug Chaperones, no. But still, I know that I'm not supposed to give out proprietary information, right? So,
without giving out any proprietary information, what can you say about sort of the scale or performance objectives?
So we took, our thing was total flexibility as far as the tables were concerned. If we had to take a hit on the bandwidth, so be it. If we had to take a hit on how long it takes to deliver, that was our trade-off that we did. And I think making it flexible kind of makes it easier for people to develop new apps, right? I mean, I don't want to be in the business of figuring out what apps should be written on the controller. If you want 20 tables, do it and see what comes out of it. So, my friend here has a comment. The scale, 64K entries you can match. I think it's way better than what we did before. Okay, should be okay for the time being. Are there other questions? You can slice and dice it, right? We need a mix of exact matches and
end-to-end L3 use cases. I think that now the software team has gone through stages and gotten to be wonderful to hear a vendor talk about. Oh yes, you have to make it generic for the controller to wait. So great. Took years to get there.
I'm from engineering, right? So marketing might be a different message.
They're not here right now. Do you think that attitude or that approach, that I'd say realization of that feedback into the hardware design? Because obviously the hardware designs today were not built with that realization.
So OpenFlow has been around for I don't know how long, right? Because I've been doing OpenFlow for 7-8 years now. We kind of waited for Broadcom and other switch vendors to come out with the OpenFlow compatible chip, and it hasn't happened yet.
Right.
So I don't think we should wait for the ASIC vendors to change their ways, right? But if we have enough switches out there that support it, they'll be forced because the volume's there. You need big customers to step up too to say that,
Sure.
money talks, right?
And also, I mean, I doubt that their engineers have realization. That realization of by enabling the controllers to be able to do whatever they want beyond what we think of as the normal obvious pipeline. That realization is huge. Once that happens, then we enable the future possible. Until everyone has that realization,
And even at a smaller level, like, can you imagine like a stacking solution which has an Arista box and a Cisco box together, right? Customers always talking about having multiple vendors in their network. Well, you can have it on the rack now,